GTRE accelerates Kaveri Derivative Indigenization to over 90% local content. In a significant push for self-reliance in defense aviation, India's Gas Turbine Research Establishment, GTRE, is accelerating the indigenization of the Kaveri Derivative Engine, KDE. This dry variant of the original Kaveri engine targets over 90% local content, supporting future Indian Air Force programs and reducing dependency on foreign suppliers. The KDE, a non-afterburning turbofan engine, is designed primarily for unmanned combat aerial vehicles like the DRDO Gatak and the remotely piloted surveillance aircraft bomber program. It delivers 48 kN of dry thrust, focusing on endurance, fuel efficiency, and stealth integration for deep strike missions. Currently, the KDE has achieved 85% indigenization through domestic manufacturing of key components. GTRE plans phased increments, aiming for 88% by mid-2026 and exceeding 90% before full operational integration, ensuring complete sovereignty over engine lifecycle management. Historical challenges with the original Kaveri engine, intended for the HAL Tejas, included turbine blade failures and insufficient thrust. Delinked from Tejas in 2008, the program shifted to derivatives, leveraging lessons for improved reliability and performance in unmanned applications. GTRE's indigenization strategy involves onboarding new domestic partners such as Larsen & Toubro and Mishra Dhatu Nigam Limited. These collaborations focus on local production of turbine blades, compressor stages, and specialized alloys, addressing past import dependencies. Godrej Aerospace has invested heavily in facilities for KDE modules, delivering units starting late 2024. Azad Engineering handles assembly of advanced turbo gas generator components, with first deliveries expected by early 2026, boosting production capacity. The engine features a low bypass ratio design with a 6-stage high-pressure compressor and single-stage turbines. Advanced materials like single crystal blades from Defense Metallurgical Research Laboratory enhance heat resistance and efficiency at high altitudes. Development milestones include ground tests validating performance, with inaugural flight tests on an older Tejas Limited Series production variant imminent. This low-risk approach minimizes impacts on newer airframes while confirming real-world capabilities. Post-Tejas trials, the KDE will integrate with the 13-ton RPSA bomber, a stealthy UCAV for complementing manned fighters like Tejas MKII and advanced medium combat aircraft. This enhances India's deep strike options in contested environments. Technical specifications highlight a dry weight reduction to 180 kg with airflow of 78 kg and overall pressure ratio of 21.5.1. These parameters support sustained operations without afterburners, ideal for long-endurance unmanned missions. Indigenization efforts draw from breakthroughs like near isothermal forging and nickel-based superalloys developed domestically. These innovations ensure structural integrity under extreme conditions, marking a leap in India's aerospace metallurgy capabilities. Bharat Heavy Electricals Limited collaborates on marine and industrial variants, expanding Kaveri's applications beyond aviation. This diversification strengthens the ecosystem for spares and maintenance, critical for high-volume IAF requirements. Challenges remain in scaling production for potential squadron-level deployments. GTRE addresses this by diversifying suppliers and investing in in-house facilities, aiming for resilient supply chains against global disruptions. The program's revival post-2014 abandonment underscores strategic shifts toward UAV propulsion. With 3,217 test hours completed by 2021, ongoing in-flight tests in Russia build confidence for 2026 integration. Economically, achieving over 90% local content reduces costs and fosters job creation in aerospace sectors. It aligns with Atmanirbhar Bharat, promoting technology spin-offs for civilian applications like power generation. Strategically, the KDE fills gaps in India's defense arsenal, countering regional threats with indigenous technology. It provides the IAF with scalable, performance-validated engines for next-generation platforms. Future upgrades include a Kaveri 2.0 variant with afterburner for 75-79 kN thrust, potentially powering enlarged Tejas versions or advanced trainers. This evolution ensures adaptability to evolving mission needs. International collaborations, while minimized, may involve competitive bidding for residual technologies. However, emphasis remains on proprietary innovations to maintain strategic autonomy in engine development. Upon full induction, the KDE will equip multiple UCAV squadrons, enhancing deterrence through stealth and precision. This positions India among global leaders in indigenous aero engine technology. The acceleration of indigenization not only resolves historical setbacks, but propels GTRE toward technical leadership. By 2030, it promises a robust, self-sufficient defense aviation framework. This milestone reflects India's commitment to innovation and nationalism, with the Kaveri Derivative driving propulsion advancements for secure skies. Stay informed with globalinfobeta.com